If you can see my screen.
Yes, we can.
Yes. Before taking questions for the projects today, I would like to show you our notebook that we've been working on for the past week. So this is wake word detection using deep sea. Uh, So we all are familiar with Siri, Alexa, and Google Assistant, right? So we use the wake word. So wake word is something that triggers the machine to listen to us. Uh, for example, if we say "Okay Google," the mobile Google Assistant turns up, right? And if you use "Hey Alexa," the Alexa turns up, and likewise with Siri. So over here, I would like to show you a custom wake word detection. Search the web for that. My mobile actually. Yeah. Using this notebook, we would like to train a neural network which would help us create our own custom wake word that you can then use to install on our devices so that it can use it. So here we go. So just like Hey Google, so we are using the wake word canvas over here uh, to it's a wake word that would wake up the machine and do anything that you would like it to. So for the data set, we have the hot word and the background. So the hot word is the word that you would like as the wake word, right? So it could be anything. For this notebook, we are using canvas. So if we say if we say canvas, then the machine would wake up. So in order to recognize that word, we're going to train this neural network. So the hot word contains the recordings that we would, that has our recording of saying canvas. So from the hot word itself, the more important is the background. So that neural network can learn how to differentiate between the wake word and everything else that is out there, right? So let's say that 90% of the words you would say in your house would be something else except the wake word, right? So the background is very important, and so these are the two things that we would be using to train our neural network. So for the data set, we have already downloaded it, and this is the link, and you can find it on the use case page. So on tapping this card, the custom wake word detection app would show up, and you can copy it to your workspace and use it. Uh, so we use we are, after that we are going to import the required libraries. So we use Librosa to convert the audio files to floating point time series, right? Because we use the time series to train our model from the audio file, right? So from that, and we are using we're setting the max length to 2 seconds of input window. So the desired sample rate is 8,000. So using that, we are setting the desired samples to max length into desired sample rate, right? And now we process the data, and we are normalizing the data because there will be a lot of variance. So normalizing it would enhance the machine learning. So we are using the difference over here to normalize it. So the max value and the minimum value, we are using that to divide the whole thing, and we normalize it, right? And so essentially there are two data sets kind of over here. So one is the canvas data set. So this is the wake word data set. So this data set would contain the time series of you saying the wake word, which is canvas over here, and the non-canvas would be anything but the canvas, like the wake word, right? So it could consist of the background noise, anything else, any other word, or even the silence, right? So we're using that, and we're loading the database. So over here, if the directory is background directory, then we are adding it to the non-canvas dataset. Otherwise, we are adding it to the canvas dataset, and we load the dataset like this. And for the inputs and the labels, for the labels, so for the inputs we have we're concatenating the both the canvas and the non-canvas dataset. So first comes the canvas dataset. So for the first n number of rows which has the canvas dataset, it will be one. So one indicates that it's canvas, and zero indicates that it's anything else but canvas, right? Background noises or silences. So over here, as you can see, the total length is 371. So that is the total number of samples that we have, and we are adding background and silence to it, so that it can also differentiate between any kind of noise or any kind of silence that might be there, right? So for we're adding background like the noise using random and the silence using zeros. And after that, you can, as you can see, the sample number becomes 471. And moving on, we randomize the data and split the data into train and test sets. Now we'd like to see whether the dataset is actually properly preprocessed, right? So we're taking a sample, a random sample, and we're using the IPD, like the audio streamer, to see what we have got, right? And we're printing canvas if the label is one, otherwise background. So over here, as you can see, for this random data, we have the label as background, and we can place this. I'm not sure if you can hear this. So yeah, this audio file does not have a canvas in it, so it's background, right? Now we're building and training the model. Now, for this network, we're for first we're using the spectra, like the spectrogram operator. So what it does is it actually takes the time series and uses short time Fourier transform to change to transform it to frequency patches, right? So that can be used by the convolution network as features, so it can work on that as features. So at first we have the layer of spectrogram, and then we are reshaping it so that convolution layer can use it. Then we have three convolution layers with ReLU network, ReLU activations, and then we flatten it, and then the output as one neuron output with the activation sigmoid, right? So this is our network over here. And as we train it, we use the optimizer Adam to optimize it, and the loss function binary cross entropy, and we monitor the accuracy. So for after 10 epochs, this is the result. So we achieved an accuracy, a train accuracy of 19% and a validation accuracy of 95%, which is pretty good. And this is a summary of the model that we have added. So over here is the spectrogram, then the switch for the convolution. And these are the convolution layers and the output layer, right? And yeah, so this is the score. The test accuracy is 95%. So within testing the trained model, within testing it on a random sample from the test dataset, right? So we're taking any a random data set from a random sample from the test dataset, and we're checking the same process is repeated over here. So we're checking if the label, we're seeing if the label is canvas or background. So over here the label is canvas. So the prediction, as you can see, the true label is one. So one means canvas, and prediction is 0.99987, so which is close to one. So which means that it's canvas, right? So if you play this, you can hear canvas playing in the background, right? So this is canvas. So it accurately predicted the sample or with the output of the
Um,
sample. So testing,
Arnab,
yeah, yeah.
you, I think you have earphones on. We didn't hear the sound canvas.
Let me stream that window. I think you can hear it
Okay.
if you can see my screen. Uh, I'm not sure if you'll be able to hear the audio. I played it. Uh,
No, we can't hear
did you
your
hear it?
audio. No, we can't
Did
hear
you
you.
guys hear it? Is it audible to you guys?
No, it isn't.
Um, okay, I guess that's something Meet doesn't do, I guess. So moving on, you can test it on your own on your own workspace. As I said, that you can use this. If you click on this, this will open up, and you can then copy it to your workspace, right? Over here, if you press on edit in Canvas, it will open up, uh, and you can, like, it has been copied to your workspace, and you can open the notebook server to use it, just like I did. And then you can test all this out, and then testing on background and silence. So the prediction is done on that, and then testing on a longer clip. So if you look into the data set, you will find that there are two long clips over here. So we're using the clip 3 to predict our output. So as you can see over here, So if you look at this graph carefully, you can see that this is the y-axis, right? So if the value is one or close to one, you can say that we have used the word like canvas in the recording, right? And it also looks upon the area under the curve. So I can explain this. Let's say that you're saying canvas, right? Any word you say, it has a duration, right? So over here, it has a duration of like 1 second, I guess, right? So it's looking for area under the curve, and if it is 1 second, and if the height is close to one, then it's saying that like it's predicting that it is canvas. The user said canvas, right? But over here, if you can see that it has not reached the total height, and also the area under the curve is not enough to consider it as a word. So we can assume that the user said like k over here, or something a part of canvas and not the whole word, right? So this is pretty cool, because otherwise, like any other word like k or any part of it would trigger the machine, and we wouldn't want that, right? This is how the network has been trained, and it can detect the canvas word or any other wake word that you might want to use. We are then extracting the submodel without the HDFT layer, and we are compiling it with libc. Right. So we have the modeler submodel.exe, which you can deploy in our edge devices, and the prediction would work. Now, in the like we're still working on this notebook. So in the future, we'd like to add a notebook cell that can record your own voice. So we'll be able to live stream whether it is predicting the correct word or not. Just like with image processing apps, right? So for face detection, we're using live stream and seeing if it can detect our face. So we'll do that over here, hopefully. And by the next lecture, I think I will have another set of data set that would work like with another wake word. And in the meantime, I would like you guys to try it out and see what you can do with it. I think it's pretty easy. All you have to do is adjust the dataset. So let me go through the dataset once again. So it has the background. So background could be anything that does not have the word your worker. It could be you reading reading a book, like any kind of book, or any kind of background noises that would not consist of the wake word. And the hot word is the place where you insert your wake word. So over here, as you can see, there are three different persons, and they're all saying canvas. Um, Over here in background, again three different persons reading the same book or different books or any other thing. And um, and and these are the test clips. So the test clips have any, like it has, like, let's say there is this platform canvas, we are using it. Canvas is AITS property and stuff, like I use a lot of words, and I also used canvas. So over here, as you can see in the graph, let's say the what I just said right now, it is interpreting that, and at moments when I say canvas, it would go up and detect it, and at other points it would fall down. Right? So that's pretty easy to use. So I hope you guys would do something with it, awesome with it. With that, I think I finished this part, and I'd like to uh, Rohit, if you could take over.
Thank you, Arnab. So this is actually new addition and pretty exciting one for us. What you can do is train your own words. So, for example, Devarsh, right? You can create a app that reacts to you saying Devarsh or Aisha or Gunjan or Anand, and you can make it your own. All you have to do is to upload the data set in a manner that Arnab explained. So by next lecture, he's going to work on and add a cell that will let you record straight from your browser. So all you have to do is to do a hot word um, recording, and then it'll upload it directly onto the dataset directory. And so that will be one recording. The second recording is you just read from the book or let it record the background noise for about a minute. And with these two data sets, you are ready to sort of roll with your own wake word detection. And at the end of the entire thing, you can turn it into an executable or something that you want to run on a microcontroller. So, like I said, microcontrollers are everywhere, right? So I would hopefully by the end of hopefully by next week, the lecture after next, we would demonstrate how we take this, convert that to deep C, and show you a component that runs the wake word detection. And when it'll have a mic, and the mic is capturing your sound real time, and then it would respond to the wake word, and that's the idea. And so the whole application, you can take it to any device, and microcontrollers are everywhere, right? So for example, if you're in your house, practically you have around 50 or so microcontrollers in your household, including few in your TV, refrigerator, a microwave oven, garage, in your car probably has over 50. Not every microcontroller has a mic. So if you want to put this into an edge device like a microcontroller, you purchase that for $5 or $10, and flash the executable that we give you out of DeepC straight onto that device, and it is on. And those devices run for months on battery. So let's say you want to create a toy, right? That reacts to, and you want to give it a name, say my toy. And every time you say my toy, it's ready to listen and do the stuff that you want it to do, right? So any functionality you add after that would be, would bring the magical touch to the toys. So, and it's not just limited to toy, right? For example, you can change your electric switches and add a microcontroller that detects like few words. For example, it wakes with a word called, say, fan. So you have an electric switch that is connected to your fan. You walk into the room and talk to your fan, say, hey fan, turn on speed 3. So that would require 3 to 5 different word detections, and responding to the command. And so the devices like that, that are not available today, you can create for your own hobby. You can create for your project, like bachelor's or master's project, or you can start a product on. You can start a Kickstarter campaign with that product and see how many people are interested. And if you get more responses, then you have a company that you can run. So a lot of ideas on this app, and it'll be exciting to see where you guys take it. With that, I am done. Arnab, do you have anything else to add?
No.
Okay, so my comment at the end is I'm excited to see where you guys take it. Look at that data set, look at the notebook, run it with different sounds, and we're going to add recording the data set straight from the browser by next lecture. So stay tuned and have fun with it. And when you have, when you have recorded or personalized it to react to your own sound, your own name, or your dog's name, or whatever have you, don't forget to share it with your friends, family, and even your social media networks to let other people know that how cool is this and how easy is this to sort of add AI or ML model to tiny devices. And with that, thank you very much. We'll see you in the next lecture. Bye now.